Hi, so this is a video discussing how to find the gradient of a linear equation. The gradient tells us how fast a graph is rising, and it tells us stuff about the slope. So, for example, how steep it is or how gentle it is. So, while we have a set of axes, we can put on a linear graph. Now, on that linear graph, we need to be able to tell certain things about it. Now, we're finding this steepness of a slope, okay, because that's our gradient. So, what we need to be able to do is we need to be able to compare this line with the direction of y and the direction of x, okay, and we'll come to exactly how we define the gradient. So, what we first do is we find a change in y. Now, the change in y is actually saying how fast is y increasing in this direction comparing to how fast the x is increasing in this direction. Okay? Now, we can actually find this out. So, if you have a look here, I know it's not quite accurate, but if you have a look here, this is our change in y, okay? This is how much we're going up by from this point to this point here. Now, the gradient won't change even if you pick a point here going up to a point here, okay? So it doesn't matter what 2 points we pick. So I'm picking this point up to this point. Now, if you have a look here, a change in y, we're going from 3 to 5 approximately. I know it's not quite accurate, but we're going from 3 to 5, so that's going up by 2 units. Okay? Now similarly, if we check the x direction, our change in x is going from 3 to 6, so our change in x is actually 3, so 1, 2, 3. Now we can put this in, so we define m to be our gradient. Okay, now we put y on the top because we're saying this is increasing. We're comparing the increase going upwards to the increase going to the right. Okay, and that's our gradient. So remember, m is the increase in y compared to the increase in x, or commonly we say that as rise over run. So we said the change in y is 2 and the change in x is 3, so let's put that in. So 2 units compared to 3 units, and so our gradient is 2 over 3. Now let's come to an example where we actually have set coordinates for us. Now we'll come to a way where we can actually just write all of this out without having to use a graph to find it manually, okay? However, we'll start off with the graph first. Now, don't be scared off by the fractions, okay? It doesn't actually mean much. You usually won't get any complicated calculations out of this, so it should be all quite straightforward, pretty easy to put in. So, we have 2 points here, we've got 2, 2, and we've got 6, 5. Okay, so, again, like before, we're going to put in the change in y right here. So 5, going from 2 to 5, so that gives us a 3, because that's 5 minus 2. And then we do the change in x, which is going from 2 to 6, so that's a change of 4. So, like before, we put that in. That's 5 minus 2, and that's 6 minus 2 on the bottom, so that gives us 3 on 4. Now, what I need you to take note here is having a look at how we're finding this. If I say that's the second point, and that's the first point, you notice that whenever we are doing these calculations, for the y part for example, on the y coordinate here, we're saying that's the second point, taking away the first point. Okay? Second point, taking away the first point, because I'm saying that one's the second point. Similarly, on the x change, we're saying the x of a second point, taking away the x on the first point, gives us a change in x. Okay, so this means that if we are given two things, okay, 2 points, if I say that's the first point and that's the second point, then the change in y is actually just the second point taking away the first point. Now, I labeled the second point saying y2 for this case, so we can say that's y2 taking away y1 like before. Similarly, for the x part, we can do x2 because that's the x coordinate of our second point, taking away the first point, which is x1, so that's x2 minus x1, which means for our gradient we would actually have the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Okay, now you'll notice that that says 2 and that says 1 always. Okay, this means that we need to be consistent with how we're labeling our points. Be very careful with that. So if we're labeling saying that's the first point, then we have to pick that being x1, y1. Note that they're both 1s. For the second point, we need to label that x2 and y2. Okay, so for any given points that we have, which is x1, y1 and x2, y2, we can find the gradient simply using this. Okay, I want you to take note of it. I want you to remember it in your head. So let's go on an example where we have just the points, no graph for us to do our checking with this. We can't, where did my mouse go? We can't actually find the change using the graph, okay? We'll have to actually use the equation that we got here. Okay, so first thing we have to do, you'll notice that these 2 points that were given are not labeled with x1, y1 and x2, y2. Okay, so if I say that's the first point, then I can label that x1, y1 being -1, 3. So x1 is -1, y1 is 3. Okay, I'll say that's the second point obviously, so there'll be x2, y2. So x2 is 4, y2 is 8. So let's put that in our equation. So y2 is 8, y1 is 3, so you should have 8 minus 3 on the top. x2 is 4, x1 is -1. Now you have to be careful here. When we put it in, on the top we said we had 8 minus 3. For the second one we have 4 minus -1, so this then becomes a plus, okay? So if 8 minus 3, which gives us a 5 on the top, 4 plus 1, remember that's a plus, 4 plus 1 is 5. So that gives us a gradient of 1. So the gradient of the line is 1. Okay? Now if you have any troubles, just have a look back through this video.